Welcome to this explainer. Okay, let's just dive right into it. I want you to imagine we are on site together today. I'm your senior network architect, and you are the brand new, highly motivated junior engineer on my team. Today, I'm handing you an absolutely critical, real-world mission. We're moving way beyond textbook theory and stepping straight into the wiring closet. You're about to configure a Cisco Catalyst switch for the very first time.
So picture the immediate scenario. You've just racked a brand new, out-of-the-box switch. You've plugged the power in, you hear the fan spinning up, all the lights are blinking green. It's great, but there's a huge problem. How do you actually manage it? You see, from a network perspective, right now this freshly racked piece of metal is essentially blind and totally isolated. You can't ping it, and you certainly can't remotely log into it.
Think of it like this. An unconfigured switch is basically like a highly secure building that literally has no doors. Until we actually configure the basic IP and security settings, we cannot remotely access, manage, or monitor this essential piece of infrastructure. And let's be honest, if you leave it like this, every single time you want to make a tiny change, you're going to have to physically walk all the way down to the freezing cold server room. We definitely need to fix that.
All right, so let's move right into phase one of our deployment workflow. First contact via console.
Because that network-based remote access isn't functioning yet, we've got to get physical. To get into our building, you need a direct physical connection. So you're going to take your laptop, grab a physical console cable, usually it's one of those light blue rollover cables, and plug it directly into the console port on the back of the switch. Fire up a terminal emulator on your machine, hit enter, and boom, you are in.
Now, what's really fascinating here is the default state of a brand new Cisco switch. By design, it allows full unrestricted access via that physical console port without asking for a single password. Zero. It's completely wide open locally, but entirely locked down remotely. On top of that, every single physical port on that switch belongs to one giant broadcast domain, VLAN 1. This default state is incredibly vulnerable to physical tampering, which is exactly why locking it down is our absolute most urgent priority.
And that brings us perfectly to phase two, basic passwords and identity.
We need to secure this physical connection immediately and give the switch a recognizable name. Let's execute your exact CLI workflow. First up, we type hostname SW1. The prompt immediately changes right there to reflect the new name. Next, we lock down privileged mode by typing enable secret love. Now, that word secret is absolutely vital here because it strongly encrypts the password right there in the configuration file. Then, we lock down the physical port itself. We type line console 0, we set the password by typing password faith, and finally, don't forget this part, we type login to actually force the switch to prompt the user for that password.
Let's just step back for a quick second to make sure we understand exactly where we are typing these commands. Cisco iOS uses this really specific hierarchical mode structure. You always start out in user mode, which you can spot by the greater than sign. That's just for really basic viewing. You type enable to jump up to privilege mode, marked by the hash sign, which gives you full viewing rights. And finally, to actually change how the switch behaves, you type configure terminal to reach global config mode. Honestly, just knowing exactly which mode you are currently in is like half the battle of network engineering.
Okay, the physical port is secure. Awesome. Let's move to phase three, bringing the switch online. It's time to give this layer 2 device a proper layer 3 presence on our network so we can actually reach it from our desks. To do this, we use something called an SVI, or Switched Virtual Interface. Think of an SVI like a virtual network interface card that lives entirely inside the switch's software, rather than assigning an IP address to a physical port. Because remember, physical ports are just for switching regular Ethernet frames. We assign the management IP address to this virtual interface, specifically interface VLAN 1. Let's actually build it out. From global config mode, you're going to type interface VLAN 1. Bam, you are now in interface configuration mode. Next, type IP address 192.168.1.200, followed by the subnet mask 255.255.255.0. And finally, you type no shutdown.
Now, let's pause for a second here. What do you think happens if we just skip that final no shutdown command? Well, I can tell you from personal experience, this is literally the #1 mistake I see beginner engineers make, every time. By default, a VLAN 1 interface is sitting in an administratively down state. If you don't explicitly tell it to wake up by typing no shutdown, that interface will literally never come online. Your switch will remain totally unreachable over the network, no matter what IP address you just gave it.
So the crucial point to remember is that an IP address alone just isn't enough. Imagine you're sitting up at your desk on the 3rd floor, right? You're on a completely different IP subnet, and you're trying to manage this new switch down in the basement. The switch actually receives your packet, but how does it reply? The switch looks at your IP and checks if you're local. You're not. Therefore, the switch absolutely must forward its reply to a router to get back to you.
To make that magic happen, you have to configure a default gateway. It's super simple. From global configuration mode, you just type IP default-gateway followed by the IP address of your local router. Let's say it's 192.168.1.1. Without this one single line of configuration, your switch can only ever talk to devices plugged directly into its own local subnet. With it, you can manage this switch from literally anywhere in the world.
Excellent work. The switch has an identity, it's secure locally, and it finally has an IP presence. So let's move to Phase 4, enabling secure remote access.
We are finally going to build our virtual doors. When it comes to remote access, you really have two main protocols: Telnet and Secure Shell, commonly known as SSH. Let me be incredibly clear here. Speaking as your senior architect, we absolutely do not use Telnet in production environments, ever. Telnet sends everything, and I mean everything, including your administrative passwords, in plain, readable text. Anyone sitting on the network with a basic packet sniffer could steal your credentials in seconds. No way. SSH, on the other hand, encrypts the entire data stream. It is the absolute industry standard, and it is exactly what we are going to configure right now.
Now, configuring SSH is a bit of a multi-stage process, so let's just break it down into a simple engineering checklist. Step 1, the switch needs a host name and a domain name. Step 2, we use those names to generate cryptographic keys. Step 3, we create a local database of usernames and passwords. And finally, Step 4, we configure the virtual terminal, or VTY lines, to strictly enforce SSH usage. Let's do it.
We already set the host name to SW1, so that's done. Next, we type IP, domain name, example.com. What happens here is the switch seamlessly combines the host name and domain name to create a fully qualified domain name, sw1.example.com. Now for the really cool part, we type crypto key generate RSA. The switch takes that domain name and uses it as a mathematical seed to generate the public and private encryption keys that are required to safely encrypt our SSH traffic. It's like magic.
Next up, we actually need user accounts to log in with, right? So we type username Wendell Secret Odom to create a highly encrypted local user profile. Now, we apply this security to our virtual terminal lines. We type line VTY 015. That grabs all 16 simultaneous remote sessions at once. Then we type login local, which forces the switch to check that username database we just created. And finally, the absolute knockout punch for security: transport input SSH. This explicit command tells the switch, hey, reject any telnet attempts and only allow encrypted SSH connections. Boom. Done.
You've engineered the solution flawlessly. But, in this industry, we don't just type a bunch of commands and blindly hope for the best. We verify. So, welcome to Phase 5, verification and testing.
Let's open up your verification toolkit. First, you'll use show running config, just to verify your syntax is totally perfect. Then, you use show interfaces VLAN 1, and you are looking for those two magic words, up and up, proving that your SVI is actually active. After that, type show IP SSH to confirm those crypto keys generated successfully and the SSH server is actively running. And finally, you issue a standard ping to your default gateway. That proves your Layer 3 routing is fully functional and traffic can actually leave the switch.
And honestly, this brings us to what is easily the most satisfying moment for any network engineer. The verification checks out, it looks totally clean. You reach around the back of your laptop, you literally unplug that physical blue console cable, roll it up, and you just walk away. You go back to your desk, open up your terminal, type in the switch's brand new IP address over SSH, enter your credentials, and the command prompt appears. The switch is no longer blind. It's alive.
Seriously, from a senior architect to a junior engineer, good job today. You took a cold, isolated piece of metal and completely transformed it into a reachable, highly secure node on our enterprise network. You've officially mastered the core fundamentals of initial device management.
But before we wrap up this explainer, let me just leave you with one final thought to chew on. We've successfully built and totally secured the entrance to our building, right? But what about all those rooms inside? Right now, every single port is still sitting in that default VLAN 1. So how do we separate, say, the accounting traffic from the engineering traffic? Take a breath, review the commands we covered today, because segmenting the network with VLANs is exactly the puzzle we are going to tackle next time. Keep practicing, you've got this, and I'll see you in the next explainer.